Alright, physical properties of fatty acids, because it's pretty, there's a couple of things that we need to know here. I just wrote them out really quickly. So describe the physical properties of fatty acids. First, as far as water solubility, their solubility decreases with increasing carbon chain length. Just like carboxylic acids, because that's what they are. They tend to, so if we start out with a very small fatty acid, we'd expect it to be more soluble than something that had a very long trailing end. So not too much different from the carboxylic acids that we've talked about before, except that we tend to have a longer trailing nonpolar end. Melting points. Melting point increases with increasing chain length, as we'd expect. As the molecule gets larger, it should take more energy to get it to go into the gas phase. The greater the degree of unsaturation, the lower the melting point. So as we add double bonds to a carbon, let's say we have a fatty acid that has 20 carbons, the more double bonds that we have present in that chain, the more bent and kinked it is, and the less it is able to interact with other molecules and form the intermolecular forces that it has to. If you have just a whole set of unsaturated molecules, fatty acids, they really have more chance of interacting with one another between the molecules. But if you put a double bond in, as we know that they tend to be cis, that brings the molecule, it bends it over and kinks it, and you lose, and you can't store as many of them close together. Picture if you have strands of dry spaghetti, you can stack a whole bunch of them into a box. But if those pieces of spaghetti were dried out into helical forms and weird shapes, you wouldn't be able to fit anywhere near as many of them in the same box. So it's just the shape of them prevents them from having the same intermolecular forces between them, and that will lower their melting point, because it won't be as difficult to break those intermolecular forces and cause them to melt.